Hello, this is Tamima Hadi. Welcome back to our next lesson. This one is called Properties of Rational Numbers. By end of this lesson, we will be able to identify and explain the properties of rational numbers and apply properties of rational numbers to simplify expressions. So, to learn to this topic, we have to know these two concepts. First, we have to able to uh, explain the properties of whole numbers and integers and operations of rational numbers. So let's begin from the definition of integers. An integer is a number with no decimal or rational parts from the set of negative and positive numbers, including zero. So, what is an integer? An integer is including negative numbers, for example, -3, positive numbers, for example, +6, and 0, but there is not, um, and this set not including fractions like 1 by 2 or decimal numbers like 0.3, for example. These are not rational numbers. So, next, closure property. So, first, let me read the definition, then we do some examples. So, when you perform an operation on two numbers and a set, the result is always a number and that same set. So whenever we pick uh, two elements from a set of numbers and we apply an operation, then the result, if we can find again, and that same set, we called that set of numbers closed under that specific operation. For example, let me consider the natural numbers under addition. So, as we know, natural numbers like 1, 2, 3, 4, etc. So, suppose I uh, do add as 1 plus 3, it is equal to 4. See, whenever I pick two numbers from this set, from natural numbers, again the result you can find in this set. So that is why we say, based on that definition, natural numbers closed under addition. Okay? Next, open properties. When you perform an operation on two numbers and a set, the result may not be and that set. And that time we say that set of numbers open under that specific operation. For example, this natural numbers open under subtraction. Why? Because if you subtract, suppose 3 minus 6, it's equal to -3, right? See, 3 is a natural number and 6 is another natural number, but product is not a natural number, right? That is why we say this uh, natural numbers open under subtraction. So let's go ahead, and this is the definition of rational number. A rational number is any number that can be expressed as P by Q, where P and Q are integers, but Q is non-zero. So if we can write a number as a P by Q, then we call this number as a rational number. This is a rational rational number, right? Rational number. So, for example, 1 by 2 is a rational number, minus 3 by 4 is a rational number, but pi is not a rational number. Why? Because we cannot write this number we cannot write as a fraction that like p and q, right? This is the definition of rational numbers. Some other example of rational numbers here. You can see all of these numbers showing rational numbers. But these two numbers are they are not rational numbers because we cannot write them like p by q. So now let's begin the properties of rational number. First one is closure property. Closure property, so rational number are closed under addition, subtraction, multiplication, and division. So it means whenever, suppose we have two rational numbers like a by b and c by d, whenever we add them, again the product will be a rational number. Or if we subtract them, again the product will be a rational number. If we multiply them, again we will get a rational number. Also, if we divide two rational numbers, again we will find a rational number. So let me do some examples here. So suppose let's begin from the addition. 1 by 2 plus 3 by 5, it's equal to, so we know that the addition of rational numbers, first we find a common denominator between these two denominators. You know it is 10, so 10 divided by 2, it will be 5. 5 times 2, 1, it is 5, plus 10 divided by 5, it's 2. 2 times 2, 3, it will be 6. So it is equal to 11 by 10. See, when we add two rational numbers, again, we got a rational number, right? So that is why we say that addition is closed, rational numbers closed under addition. The first example, second example, we can write, for example, 4 by 7 minus 5 by 7. See, we know that uh, from the same denominators, we select one of them and we do 4 minus 5. It is equal to minus 1 by 7. See, again, we got a rational number. So that is why we say a rational number is closed under subtraction. Same we can do for multiplication. Suppose we have first example like 4 by 3 times to 1 by 7, it's equal to 4 by 21, right? See, again, we uh, can see it is a rational number. So that the rational numbers closed under multiplication. Same, we can do another example to divide two rational numbers. For example, 10 by 3 divided by 2 by 9, it's equal to, so we know how we divide two rational numbers. You can write 9 by 2, it is equal to 19 19 by 6, right? And also you can simplify uh, 2, 3, 6, 3, 2, 3, 9, 0 is equal to 90. Once again, you can simplify, it will be 15. It's 15. See, again, you know that 15 is a rational number, right? So here are some more examples. If you're interested, you can pause the video and do these examples also. You can see that addition, subtraction, multiplication, and divisions are the rational numbers closed under these 5 operations. So the second one, commutative property. So uh, as we know from the properties of whole numbers, suppose if we have a plus b, then we can write it is equal to b plus a, right? For example, if we have 3 plus 2, it is equal to 2 plus 3, right? The result will be same. See, the both side right and left, that's equal to 5. The both side is equal to 5. So same thing we can apply to rational number as well. For example, uh, we can write uh, 5 by 6 plus 1 by 3 is equal to 1 by 3 plus 5 by 6. So see the two sides, the result will be same. So at the left side, you can select 6 as a common denominator, then it will be 5 plus 2 is equal to the next side again 6 is common denominator between these two fractions. It will be 2 plus 5. See, right, left side is it is 7 by 6, and also the right side is 7 by 6. See, there is no any change in the result is same whenever you replace and the place of two rational numbers. Same thing we can do in case of multiplication. Suppose if we this second example, if we have uh, 5 by 3 times 2 by 6, it is equal to 2 by 6 times 5 by 3. So the both side, the result will be same. Let's do the left side is you how we do? We multiply the denominators, then the numerators. Yeah, multiply denominators. It will be 5 times 2 is 10 by 18, right? It is the left side and right side. 2 times 5, it is 10. And uh, 6 times 3, it is 18. Again, we got the same result and both sides is the same. So the third one, there is called associative properties. Associative properties, it means so as we have an uh, whole numbers, like suppose if we have a plus b, then plus c, it is equal to a plus b plus c. You can apply this property and rational numbers as well. So suppose a by b, c by d, and e by f are three rational numbers. We can write same. You can add a by b plus c by d. Then you can add this result by the third rational number. or you can write the first rational numbers, then the two others, second and third numbers. Here are some examples. See, we have a by b plus c by d plus, sorry, 1 by 2 plus 1 by 3 plus 1 by 4. The 1 by 2 plus 1 by 3, then plus 1 by 4. So it is equal to 1 by 2 plus 1 by 3 plus 1 by 4. So if you add the both sides, the result will be same. Let's do it. So inside the bracket will be 6. 6 is the common denominator between these two fractions. Here we can write 3 plus 2, again plus 1 by 4, and the right side you can write 1 by 2 plus here 12 is the common denominator between these two fractions. It is 4 plus 3. So we added these two uh, fractions. So 12 is the common denominator. Common denominator divide by each denominator and multiply the result to numerator. So 12 divided by 6, it will be 2. 2 divided by 3 plus 2, 5. 2 times 2, 5, it is 10. 10 uh, plus 12 divided by 4, it will be 3. 3 times 2, 1 is 3, right? Is 3. So is equal to 3. And also the right side, we can select 12 as a common denominator. It will be 6. 6 times 2, 1, 6 plus, so 12 divided by 12 at 1. 1 times 2, 7 is equal to 7. So 10 plus 3, it is 13 by 12. And right side also 6 plus 7, it is 13 by 12. See, the result is same. So same thing we can apply and multiplication as well. So suppose here we can write 1 by 3 times 2, 2 by uh, 3, then you can times 2, 1 by, let's do a little, select the easy one, 9 by 2. That is equal to 9 by 2. Sorry, it's equal to 1 by 3, and then times 2 these two other number, 2 by 3 times 2, 9 by 2. So right side is equal to, you can multiply these two. It will be 2 by 9 times 2, 9 by 2 is equal to 1 by 3. Then times 2 inside the bracket will be, so we can cut this one by this one, and 1, 3, 3, 3 times the 3, it will be 9. So this 1, 3, 3, this 2 we can cut. So right sides will be, right side is 1, right, and left side is also, you can cut 9 by 9 and 2 by 2. This side is also equal to 1. So here are some more examples. If you're interested, you can pause the video and do these examples also. It is good. So it is enough for today, and some other important and very nice properties of rational numbers here. I will explain them in the next video. Have a good